So this question they said given that your function by using first derivative, find first your function increasing and decreasing. So before you want to find your function increasing, decreasing, you have to find out your critical value, right? Right? So how to find your critical value? Differentiate. Find your first derivative. Then we let it to 0. Then this quadratic we factorize. 3x minus 4, x plus 4. So you have two critical values. So this is your two critical numbers. So to identify its increasing, decreasing, what we need is your first derivative test to see the tangent. Yes, to see the table. We need to use the first derivative test in table. See which interval is increasing and which interval is decreasing for the tangent. So we identify the interval first. You have 2 points. So your column here will be having 3. Arrange your point in order. The smaller here is x equals to -4, then following by x equals to 4 over 3. So the interval will be x less than -4 and x is between -4 and 4 over 3, then after 4 over 3, more than 4 over 3. So we just find some test value to put into our first derivative to identify the tangent. So what's the test value that we can find here? This one, let's say -5. This one, in between, I can take 0. This one more than 1 point something, we just put 2. So substitute this in this. You can use your calculator. You set your calculator to 3 alpha x squared plus 8x minus 16. Then you press calculate. Calculate -5, enter. Calculate 0, enter. Calculate 2, enter. Positive, negative, positive, going up, going down, going up. So which interval? Function is decreasing at the interval -4 until 4 over 3. So actually from this point of view, from this first derivative, we also can see the coordinate 4 at x equals to -4 is a maximum point. The coordinate 4 at x equals to 4 over 3 is a minimum point. But this question, they didn't ask us maximum point, minimum point. They just asked us to identify where it's increasing, decreasing. So after that, the point of inflection. How are we going to find the point of inflection, if any? So from critical point here, can we identify here got inflection point or not? From critical value here, can you see any inflection point? From critical value here, can you see any inflection point? If the inflection means they were going up, or going down, they won't change the tangent. So from here, we can't identify any inflection point. But does it mean inflection point not exist? No, inflection point maybe happen at second derivative. So from first derivative, you get your critical point. Your point can be maximum, can be minimum, can be inflection. But if you can't see your inflection point in your first derivative, it might be happen at your second derivative. So the question asks you if any. So find out your second derivative. 6x plus 8. Let it to 0. 6x plus 8 equals to 0. So x equals to -4 over 3. So what's your y coordinate? We substitute that into the function. -4 over 3. Can you calculate what's your y coordinate here? What's your value? Help me calculate. What's your y coordinate? 7, 0, 4 over 27. So is it mean that this one is inflection point? Is it means that this one is inflection point? Can we say this one is inflection point with conclusion here? Can or not? Not yet. So inflection point, you have to do your test also. You have to verify is it an inflection point. So we do our second derivative test, see the concativity got changed or not. If you want to do first derivative, also can. But is it by using first derivative test? So for here, not suitable for use second derivative test to see the concativity. We need to continue with your first derivative test. So, alright. So we find out the interval and what's your test value. Continue with first derivative test to identify our inflection point, to verify out the inflection point. So the x here is negative 4 over 3. We want the interval before negative 4 over 3 and interval after negative 4 over 3. So the test value you want to choose here. What's the test value you want to choose here? You have to be careful. You cannot overtake the point that over the interval since you have other critical point. Look at your critical point. We have negative 4. We have 4 over 3 plus currently maybe inflection point negative 4 over 3, right? Arrange in order negative 4 over 3, negative, arrange in order negative 4, negative 4 over 3, 4 over 3. So the test value that we want to take less than negative 4 over 3, but you don't take too far after like this negative 5, too far away. Alright? So when you're too far away, you are testing on after your maximum point already. So we are taking the value of negative 2, but not exceed the negative 4. And negative 4 is another critical point. This is our critical point. This is our critical point. This one, don't know what's your inflection point. So when you want to test value more than negative 4 over 3, don't exceed 4 over 3. 0 can or not? 0 can. When we substitute inside, positive, this one, negative, first derivative, going down, going down, going up. When you 0, refer to your first derivative. When you 0, negative. When you're negative, negative also. Is it? Negative. So both tangent going down, then only we can verify that, conclusion that this is inflection point. So remember, you have to do your test to verify maximum point, minimum points, and inflection point.